Okay, so we are going to begin a new unit of work. We will be focusing on solving problems using three-digit numbers. Earlier in the year, you've worked on adding and subtracting two-digit numbers, so you already have some really great strategies to use. In this lesson, you are going to be able to review those strategies that you have already learned, and you will be able to apply them to work with three-digit numbers. You will need to have a piece of paper next to you so that way when I go along with the lesson, you can work with me. At the very end, there will be an exit ticket that you will fill out and submit to me on the next slide of your PowerPoint. Good luck!
Let's begin with our number routine. Which equation is represented on the number line? Pause the recording while you decide. Did you notice that there are three different colored lines above the number line on the screen? The red number line shows 50 shells found at the beach. The blue number line shows 19 shells that broke, and the green number line represents the unbroken shells, but we don't know how many that is. We do know by looking at the two lines that the green line and the blue line put together are the same as the red line. So when we think about that, we have two parts, the green part of the unbroken shells and the blue part of the broken shells that when you put them together represent all 50 shells found at the beach. Therefore, we could take the 50 shells that are found at the beach and subtract what we know, the 19 shells that broke, to find the broken shells at the beach. And there's our equation. For this problem, you will need a sheet of paper and a pencil. On your paper, draw a number line like the one is shown here. Notice the number line is counting by fives, and there are tick marks or little lines between each number to show counting by ones. How many tick marks are there between each number? Pause the recording while you do this. Once your number line is ready, come back and we will look at the problem again together. Read the problem. Caesar was 19 inches long when he was born. He has grown 23 inches. Use the number line to draw line segments that show his length at birth, his growth since birth, and his total height. Pause the recording while you solve the problem. Start the recording again when you are ready. Do your line segments look like this? Because Caesar is continually growing, there is one long line. However, it is broken into two segments to show how tall he was at birth, and we usually say this is how long the baby is since they can't stand up yet, and then how tall he is now as he continues to grow. Let's look at that more closely. We measure a baby from feet to the top of the head to find out how long he or she is when they're born, just like we would measure you now. Caesar is 19 inches long, so the first line segment starts at 0 and stops at 19. Let's mark that. Right there at 19. That wasn't a very good mark. Let's see if we can make that a little better. Right there at 19. And it says that Caesar grew 23 more inches. So if we start at 19, we can jump 10. That will take us to 29. Whoops, let's see if we can get that to show. 29. Then we can jump 10 more. That will take us to 39. So far we've jumped 20 inches and we need to go 23. And then we can jump 3 more. 1, 2, 3. Plus 1, plus 1, plus 1. And that will take us to 42. So we jumped a total of 23 inches from the time he was born at 19 inches. And his total height is 42 inches. At the bottom, the equation would be 19 inches plus 23 inches is 42 inches. In kindergarten and first grade, you began to work on decomposing or breaking apart a number into different ways. For example, you might have said, I have 6 jelly beans. 5 are green and 1 is orange. Or you might have said, I have 6 jelly beans. 4 are green and 2 are orange. Of course, you know that there are other ways to make the number 6. But being able to compose or group and decompose or break apart numbers is important with larger numbers as well. We are going to play a game called 2 Truths and a Lie. There are 3 equations here. 2 are true and 1 is false. Which one do you think is false or the lie? Pause the recording while you figure it out. Then circle the lie on your recording sheet and tell how you know it is not true.
We're going to use the base 10 blocks that you can find in your Ready Classroom mathematics dashboard to prove whether each of the equations that we looked at that go with 67, if they're true or false. So you may have used these before on your own. You've probably used base 10 blocks at school. But if you don't know how to use this virtual manipulative, I'm going to show you how to do it as we go along. So the first problem on your recording sheet says 67 equals 50 plus 17. So we need to make the number 50 plus 17. So I'm going to look up here at my base 10 blocks, and just like the regular base 10 blocks, I have a flat that represents 100, a rod that represents 10, and a small square, a cube that represents 1. So I'm going to click on the tens so I can make 50. Then if I come over to the other side, I'm going to click on this grid right here, and it will organize them a little more easily for me to see. I can count them, see I have 10, 20, 30, 40, 50. And now I need 17 ones, so I'm just going to click 17 times. And then again, I can click, and it organizes them. So as I look here, I think, all right, I have five tens or 50 and 17 ones, but I'm trying to decide if that is the same thing as 67. I think that when I see all of these ones, I'm pretty sure I have a group of 10 that I can group. So I'm going to click outside of the little blocks and hold it down and drag across to collect 10. 2, 4, 6, 8, 10. And then you'll notice it gives me the option to group them together. So I've made another 10. So now instead of having 5 tens, I have 6 tens. And I can again click over here and group them together. So I have 10, 20, 30, 40, 50, 60. 1, 2, 3, 4, 5, 6, 7, 67. So 50 plus 17 is the same thing as 67. The next problem was 67 is equal to 40 plus 27. I'm going to clear my board, so I'm going to come to here and reset my board. It asks me if I want to clear my work, and yes, I do. I'm going to pick a different color. I think I'll just pick green. And this time I want 40. 10, 20, 30, 40, and 27 ones. So I'm going to have to click them 27 times. 3, 4. here, this is a group of 27. There's 9 in each column. So I can decide, is this the same thing as 67? 40 plus 27 ones. So I'm going to, again, click outside, drag and get 10, group them together, makes a 10. If I think there's another 10, but what I discover is I can't get it to click and drag while this one's here. So I'm going to move it over with the other 10s and see if I can find another group of 10. Group them together, and again, move them together. And I have 10, 20, 30, 40, 50, 60, 1, 2, 3, 4, 5, 6, 7, 67. So 40 plus 27 is the same thing as 67. So that must mean that our last one, 50 plus 7, is the lie. If we look at what we have right here, right now we have 60 plus 7. So in order to have 50 plus 7, I would need to remove one of those 10s. You can see there's a trash can right there. And if I do that, if I take this one away, will it be the same as what you see right now? Of course not. It's not going to be the same once I take one away. So if I do that, it leaves me with 10, 20, 30, 40, 50, 7. So 50 plus 7 is not the same thing as 60 plus 7 or 67. This is 57. So these blocks are available for any time you need to add or subtract. You can use them from your dashboard and explore with them even. Let's look at this problem. Farmer Alex grows vegetables. In one vegetable patch, he planted some tomato plants. In another vegetable patch, he planted some pepper plants. How many tomato and pepper plants did Farmer Alex plant on his farm? Before we jump in to solve this, let's think about what we know. What is this problem about? Think about that. Did you say it was about a farmer growing tomato and pepper plants? Because that's what it's about. What do we want to find out? We wanted to find out how many tomato and pepper plants Farmer Alex plants on his farm. And what is it important to know in order to be able to answer that question? Well, we have to know how many of each plant there are, don't we? And right now, we don't see any numbers. So now, let's read the problem again. Farmer Alex grows vegetables. In one vegetable patch, he planted 36 tomato plants. In another vegetable patch, he planted 48 pepper plants. How many tomato and pepper plants did Farmer Alex plant on his farm? How would you solve this problem? Think about strategies that you've used earlier in the year. If you would like to use base 10 blocks, you can find them on your Ready Classroom Math dashboard. Click on the Tools icon. Pause the recording while you work out the problem. Did you do an addition problem like this? 36 plus 48? Because we had to find the total number of plants Farmer Alex planted, we needed to add the 36 tomato plants and the 48 pepper plants together. One strategy that you might have used is adding with your base 10 blocks. So you may have gone to your tools and used those to put your base 10 blocks together. This is what they would have looked like from your toolbox. Or you may have done the same thing, but instead you used a quick draw of your blocks that might have looked something like this. For your 10s, you simply drew a stick.
And for your ones, you drew a little box or a dot. Then you could group your tens together and your ones together to add. Let's see what that would look like. I could group my tens and I would have 7 tens, which is 70. And then I could group my ones. Let's find another color for that. And I would see that there are 14 ones, which is 14, and I could add together 70 plus 14 to get 84 plants. So that's one way that you could have solved the problem. Let's see if there's another way. You might have started by writing the problem 36 plus 48. And then using expanded form to solve it. I know that 36 can be decomposed into 3 tens, which is 30, plus 6 ones. And I also know that 48 can be decomposed into 4 tens, or 40, plus 8. And now I can solve that problem. 30 plus 40 is 70, plus 6 plus 8 is 14. I see here that 14 is made from 10 plus 4. So if I add that to 70, 70 plus 10 is 80, plus 4 more is 84 plants. Or maybe you wrote your problem like this. And you started by saying, well, I know that 3 tens plus 4 tens is 7 tens, and 7 tens is 70. So 30 plus 40 is 70. And I know that 6 ones plus 8 ones is 14 ones. So now that when I add that, I can see that 14 ones is actually made from 1 10 and 4 ones. And if I add that together, I see that that makes 84 plants. Or you may have said 36 plus 48. And instead of starting with your tens, you might have started with your ones. 6 ones plus 8 ones is 14 ones. And 3 tens plus 4 tens is 7 tens. And 7 tens is 70. And when I add it together, I get 84 plants. What do you notice between the two problems? Right, they both have the same partial sums, 70 plus 14. They're just in a different order. But we know that when we add numbers together, it doesn't matter what order we add them in, we still get the same sum. So we got 84 plants both times. Another really good tool that we can use for adding and subtracting is a number line. So you may have used a number line to solve your problem. I'm going to start with the 36 tomato plants, even though you know that you can start with either the 36 or the 48. I'm going to start with 36. And I also know that 48 is made up of 4 tens plus 8 ones. So I'm going to start by jumping the 4 tens, which is the 40. I'm going to jump 10 at a time. Plus 10, that takes me to 46. Plus 10, that takes me to 56. Plus 10, that takes me to 66. Plus another 10 takes me to 76. So now I've jumped 40, or 4 groups of 10s, and that leaves me with 8 ones. Because I'm at 76, I'd like to work with a friendly number. And I know that numbers ending in 0, which is when I count by tens, that those are friendly numbers. So after 76, my next friendly number that ends in a 0 is 80. And if I need to get from 76 to 80, I need to make a jump of 4. Well, that jump of 4 comes right out of my 8 ones. And I also know that 8 ones is made up of 4 plus 4. So if I jump the first 4, now I need to jump the second 4. When I jumped the first 4, it took me to 80. When I jump the second 4, it takes me to 84. And there are the 84 plants that Farmer Alex planted. So I can jump by jumping individual groups of 10s and then deciding how do I want to break up my ones. Or there are other ways that I can jump too. We're going to take a look at 2 of those. Remember, there's lots of ways you can break apart numbers to make them work for you. So we need to learn to think flexibly. And that simply means being able to decompose numbers and compose them for what we need them to do. So we practice that as we think about what's the best thing to do. All right, so with our last number line, we jumped by breaking apart the number 48. We're going to draw another number line to see how else we might have jumped, still starting with 36. But instead of breaking 48 into 4 groups of 10s and 8 ones, we're just going to use 48 as 40 plus 8, because this would be less jumps. If I know that 48 is made of 40 plus 8, and I know that I'm at 36, I can make a nice long jump of 40, and 36 plus 40 is 76. Then I can break my 8 down as I did before, if I need to do that, so that I have a jump of 4 to 80 and another jump of 4 to 84. And there are my 84 plants. That's just a quicker way to jump on the number line. Okay, so one more way that I want to share with you for looking at this problem on a number line is to again start with 36. But instead of adding 48, let's think of a friendly number that 48 can become. Remember, we said that friendly numbers often end in 0. And so the closest number to 48 that ends in a 0 would be, do you know? Right, would be 50. So I'm going to jump, instead of jumping 48, I'm going to make a big jump of 50. And I could also have jumped by 10, 5 groups of 10, but I just made one big jump of 50. 36 plus 50 is 86. But remember, I don't need to add 50, I need to add 48. How many more did I go beyond 50? I added 2 more. So I'm going to have to jump back 1 and then another 1. So I'm going to actually subtract 1. This would take me to 85. And this would take me to 84. And there are our 84 tomato plants, or plants that Farmer Alex planted. So when we use a number line, we can break apart either number and we can jump in big chunks, or we can jump in smaller ones if we need to. So today we reviewed strategies that you learned earlier in this year for solving two-digit problems. Those strategies shown here are the grouping with base 10 block strategy, the expanded form strategy, and the partial sum strategy. Even though they may not look, they may look a little different, they are all alike in some ways. On your recording sheet, pick two of these strategies and tell how they are alike.
So for your final task today, this is to select one of the strategies that we reviewed today and solve this problem. Make sure you work it out on paper and show your thinking on your paper next to you. This is the question for your exit ticket. There are 27 boys and 34 girls on the school bus. How many children are on the school bus? After this video, go to the next slide to submit your answer.